So where were we? We are in condensation method. This is a method by which the preparation of lithographic colloids was done. Uh, so in case of condensation methods, we we can prepare the lithographic salts by addition of non-solvents. Sulfur is soluble in alcohol. A concentrated alcoholic solution of sulfur is poured into an excess amount of water. The sulfur, which is present in a molecular state in alcohol, gets precipitated out as finely divided particles. These particles grow rapidly and form a colloidal dispersion. Acetone is also used in this method. Next, by chemical methods. Chemical reaction may be carried out to prepare lithographic salts. These methods are largely restricted to inorganic substances. Some examples are there, like reactions like reduction, colloidal dispersion, we will get gold, silver, platinum. Reactions like oxidation, we will get sulfur. Reactions like hydrolysis, the colloidal dispersion, ferric oxide. Reactions like double decompositions, the colloidal dispersions, which we will get arsenic oxide. So, lithographic colloids, the colloidal particles having a very little or no attraction for dispersion medium, that is solvent heating. And these particles are inorganic particles like gold, silver, sulfur, and dispersion medium like water. These colloids are easily precipitated on the addition of small amounts of electrolytes by heating or by shaking. And these are less stable as the particles are surrounded with only with a layer of a positive or negative charge. And once precipitated, it is not easy to reconstitute the salt by simple mixing with the dispersion medium. Hence, these salts are called irreversible salts. So, not obtained simply, uh, and therefore need special method for preparation. So, lithographic colloids, the method to prepare lithographic colloids, I have already discussed this dispersion methods. Coarse particles are reduced in size by ultrasonic generated electric or colloidal mill. I have told two discs are there, which rotate. One disk is rotate the opposite rotation of another disk. Next is ultrasonic generator, where dispersion achieved by high intensity at a frequency more than 20,000 cycles per second. Next is electric arc. By electric arc method, it involves the production of an electric arc within the liquid and dispersion achieved by intense heat generated by the arc. So some metal of electrodes dispersed as a vapor then condensed to colloidal particles. Then next one was a colloidal mill. The material sheared between two rapidly rotating closed plates. Low efficiency and reduce the size of small proportion of particles only. This is electric. This is a picture of an electric arc. Here the dispersion medium is here water and potassium hydroxide, and this is ice, the two electrodes, positive charge and negative charge. And next, next I have already told that condensation methods. The materials of subcolloidal dimensions are caused to aggregate into the particles with colloidal size range by change in solvent chemical reaction. So change in solvent, then supersaturation occurs, then formation and growth of nuclei, the colloidal system formation. Examples are sulfur and alcohol in excess of water. Then chemical reaction, I have already told that by oxidation we will get the sulfur salt. By reduction we will get the gold, silver and platinum salt. By hydrolysis, we will get the ferric oxide salts, and by double decompositions, we will get the arsenic sulfide salts. Okay, so these are all the methods of prepare lyophobic colloids. Next is association colloids. Certain molecules or ions terms amphiphils, which are surface active agents. They are characterized by two distinct regions of opposing solution affinities within the same molecules or ions. See, I have told previous units surfactants have two portions like head group and tail group. The head group is hydrophilic or water loving, and tail group is hydrophobic or solvent hating or lipid loving, lipophilic. So, association colloids at a low concentration, amphiphils exist separately, that subcolloidal size. At higher concentration, form aggregates or micelles, 50 or more monomers, that is colloidal size. So, amphiphils are molecules or ions which have certain affinity for both polar and nonpolar solvents. In water, at low concentrations, surface active agents exist individually as monomers, which are subcolloidal in size. As the concentration increases, the monomers aggregates themselves over a narrow range of concentration. These aggregates are called as micelles. Each micelle may contain around 50 monomers and size may be about 50 angstrom. This size falls into the colloidal size range, and they are designated as colloidal system. The concentration at which the micelle forms is critical to qualify them as colloids. So critical micelle concentration CMC is defined as the concentration range of surfactant at which the micelle start forming. So critical micelle concentration is a concentration range and has unit of concentration such as weight by weight and weight by volume percent, moles per liter, moles per 1000 gram of solvent, etc. The phenomenon of micelle formation is as follows. Amphiphils are the molecules or ions which have certain affinity both for polar and nonpolar solvents. The hydrocarbon chains is designated as a tail and the polar portion is indicated by the head. Thus, the surface active agents are represents as like this: the hydrophilic head or polar head, and hydrophobic tail, the nonpolar tail. So here the surface active agents preferentially get absorbed at air-water interface. As the concentration of surfactant increases, molecules get accumulated progressively at the interface. In this process, at one particular concentration, the interface gets saturated, while the bulk phase is saturated with monomers. The formation of micelle is so spontaneous that it is difficult to differentiate the concentration related to the saturated phase and micelle phase. So I will repeat this part the next class.